Welcome to the class of science, to be particular chemistry. Okay, this is science paper 2. Still under more concept. This is what we are looking at. But today, remember we are moving bit by bit. Today we are calculating more to more calculations. Okay, more to more calculations. And these are some of the questions that I've sampled from different past papers, as you may be aware. The first question says, how many moles of chlorine are required to react 2.5 moles of calcium to produce calcium chloride? Okay, and this is the word equation. So calcium plus chlorine is equals to calcium chloride. Calcium in a solid state, this one chlorine gas state, then chloride solid state. That is what these letters you are seeing means. Okay, so now how are we going to calculate now the moles of chlorine, okay, that are required to react 2.5 moles of calcium to produce calcium chloride? So what we are going to say, remember where we are coming from. We talked of the moles, how many moles are in one element, one compound, molecule. We looked at that. So now, here now, for us to handle this question, for us to answer this question, we'll say one mole of calcium is the equivalent, or maybe we'll just say equals to 1 mole of what? Chlorine. 1 mole of calcium is equals to 1 mole of chlorine. They are saying how many moles of chlorine. Since they are saying how many moles of chlorine, we have to start with the mole, but they are just one and the same. So now we are given 2.5 moles of calcium. So when 1 mole of calcium is equals to 1 chlorine, what about 2.5 moles of calcium? So we are going to say 2.5 moles of what? Calcium is equals to X. For chlorine we don't know, and this is what we are looking for. How many moles of chlorine? This is what we are looking for. Remember, when we are looking at this, we have to do the direct proportion. That is what is happening. Okay, and here we are just concentrating on what? Moles. There is nothing like relative atomic mass, relative molecular mass. We are already given the moles. So our area of interest is just mole, according to the question. How many moles? Here we have 1 mole, we have 1 mole, we have 2.5 moles. So how are we going to answer this one? So here we want to find the value of X, okay? And once we find the value of X, that will be the number of moles that actually required to react with 2.5 moles of calcium. So how are we going to find? Here we cross multiply. That is the direct proportion. So X times 1 mole of calcium. So X, 1 mole calcium. Okay, I've multiplied. Then equals 2.5 mole of, so I'm going to say 2.5 moles of what? Calcium times 1 mole of what? Chlorine. So here, as always, this is mathematics. We want to remain with the value of the X here. How do we do? We are going to divide by both sides. 1 mole times calcium. That is of calcium. 1 mole, I think I should even indicate there, of 1 mole of calcium, both sides. Okay, so we are going to say over 1 mole of calcium. Even this side, 1 mole of calcium. So this will cancel, then we are going to remain with x. X is equals to 1 more, just 1 more, because when you say 2.5 more times 1 more of chlorine, I forgot to indicate the more here, 1 more of chlorine. So 2.5 times 1, because our area of interest, as I said in the first place, is more. So we are just calculating more. That's why here the subtopic saying more to more calculations. So 2.5 more times 1 more is 2.5. It's 2.5. Let me write here. This is x is 2.5 over 1 more of calcium, which is 1 there. So therefore x is equals to 1 into 2.5 is 2.5 moles. So how many moles of chlorine are required to react 2.5 moles of calcium? Is 2.5 moles of chlorine. These are the moles actually that are required to calculate the what? Required to react with 2.5 moles of calcium. That is how we calculate moles to moles calculations. Then we go to the next example. How many moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose? Okay. So for this one, actually, I did not write the weight equation. Mostly, when we are given this question, weight equation is always there. I mean, chemical equation. Okay? Plus 6 carbon dioxide. Then the reactant is 6. 6 carbon dioxide plus 6 water. Okay, so that is the reaction which is there. Okay, so we are given the reaction there now. So how we are going to move from here is that 1 more of this is the chemical formula for glucose. Okay, glucose chemical formula for glucose is C, carbon 6, hydrogen 12, and oxygen 6. That is the chemical formula. Then this one is for carbon dioxide. There we have carbon dioxide. Then we also have, in fact, this is oxygen, not carbon dioxide. This is oxygen, 6 oxygen. Okay, 6 oxygen. This is oxygen. So this is our reactant and this is the product. Okay. So now, according to the question that we have, they are saying how many moles of carbon dioxide, moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose. Okay? According to the equation that we have. Okay, so here now, solutions, we are going to say 1 more of glucose is actually equivalent to the first compound, and the first one there is equivalent to what? 6 moles of carbon dioxide. Okay, how many moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose? So what about 2 moles of glucose? Here we don't know, so we are going to put x. Okay, so 1 times 1 more there, we are going to, or I mean x times 1 more, cross multiplication, this is direct proportion. Okay, so this times this one, then this one times this one. So when we multiply there, we are going to have more than of glucose, then equals, when we multiply this one, in short here, instead of even writing all these, we can just get the numbers, okay? Whereby we say 2 moles times 6 moles, what are we going to have? 12 moles. Then over, this is 1 mole, so we are just going to say over 1, even this side over 1. So this will cancel everything there. They are going to remain with x. 1 into 12 is 12 moles. How many moles of carbon dioxide will be produced by complete combustion of 2 moles of glucose according to the equation? 12 moles. Okay, 12 moles of carbon dioxide. Okay, these are the moles which will actually be produced by complete combustion of 2 moles of glucose. Thank you so very much. Actually, the exercise is going to be posted soon in the discussion group for chemistry physics. Thank you.